Thanks for coming to our session. This is ArcGIS Pro SDK 4.NET map authoring and exploration. My name is Wolf Kaiser, and next to me is Uma Harano. She's going to do the second part of this session. Let's get right into it. It's pretty warm in here, so try to stay with us. We had an earlier session where it was too cold, but looks like it's nice and warm here. So quick session overview. We're going to talk about the map tool, which is the base class for interactions with map views. Then be applying the map tools to using graphics overlay. We do map tools used for selection and identify, map tools used for custom pop-up. Then we take a look at the MapControl. That's one of the controls that's new in 1.4. And then finally, we're going to show you the feature layer renderer and various ways how to render your features. Okay, first the map tool. This is a base class representing a tool to perform interactive operations with a map view. It's used to create custom tools for selection, identify, or editing. And it provides virtual methods for keyboard and mouse events as well. Provides properties to set the default behavior for the left click to create a sketch. And it provides virtual sketch complete and sketch canceled methods. It sounds a little bit complicated, but in essence, if you use our templates out of box, we stub out all the code for you. And this is what some of the stubbed out code will look like. You can see our My Basic Sketch Tool 1 class here derives from the base class of the API map tool. We override the constructor and we use the isSketchTool equal to true property. What this indicates is that this sketch tool will actually sketch something on the screen as you use it. Then we select the sketch type, which in this case is a rectangle, and then the sketch output mode, which by default is map. It can be map or screen. I'm going to explain that in a little bit when we go through one of the samples. Below you see one of the overrides, which is the onSketchComplete asynchronous. This event or this method gets called by the map tool base class as soon as the sketch has been completed by your operator, and it provides you with the geometry that's the resulting geometry from the user sketch. And we're going to play with that too in a sample very shortly. So here a little bit on the sketch callbacks. There's callbacks after the sketching is completed. There's really, if you come from an ArcObjects background, there's no need to rubber band the feedback via the mouse move, etc. That's not really necessary. That's all built into the base class. And a sketch geometry is the parameter of the callback itself. So the sample you see below here is you see the override method that we can override in our class, the onSketchComplete async, gets called with geometry. And then we have to run the selection that we want to do here in the context of a qtask.run. That was something that we covered in an earlier session today. And qtask.run is the task scheduler from the ArcGIS Pro framework. And qtask.run provides the context for your methods to run asynchronously within that task scheduler of ArcGIS Pro. So in this case, we tell that task scheduler to perform a selection of features using the intersecting of the sketch geometry. And then we zoom to that selection using, I guess, a time, 1.5 seconds, some specialized parameters. Okay, now to the first demo. So what I want to do here is, I guess first I have to open Visual Studio. Must have closed it earlier. So what we do is we want to create a new project. Let me move this a little lower here because I think I get some feedback here. So I'll create a new project. Since I installed the ArcGIS Pro SDK on my system, I have all the templates available both for projects and also for item add-ins. What I do here is I select the module add-in, which is a standard add-in. I can also create a project which is ArcGIS Pro Managed Configuration. That's something that you saw earlier today in the plenary, and we have a session on this tomorrow. We'll show you a little later when we have all the sessions. So let me create this new project, this new add-in from a template. And Visual Studio will stub out all the code that I need from me automatically. There's nothing that I have to do. You can see we create a config.damo file which contains the markup language that we use to define our user interface in ArcGIS Pro. That's all stubbed out for us. In this case, we have a module, we have groups, and we have controls that are empty. So now I can utilize the item templates. So I say add new item. And again, I drill down to ArcGIS, ArcGIS Pro add-in. And one of these item templates is Map Tool. So I select Map Tool. I add it to the system. And again, the templates will stub out all the code that I need to run this. So I can run this actually out of box. So when we look at some of the stubbed out code, this is something that you will recognize from the slides we just saw earlier. Here's the tool activation code that I can override if I want to perform some custom action on tool activation. And here's our sketch complete asynchronous. So in this case, here what I want to do is I want to use the geometry that I receive as a parameter right here. And using this geometry, I want to perform a selection on my data set, and then I want to zoom to that selection. So let me insert that code right here. And again, what you see here, I have to run this within the context of QTask, which is the task scheduler within the ArcGIS Pro framework. Because I just inserted this code, Visual Studio helps me to find out, set up the proper namespace so I can select using ArcGIS Desktop Framework threading tasks. So now it knows what QTask is. Also, because in this demo, I want to utilize this tool both on two-dimensional data and on three-dimensional data, I'm going to change my output mode that's defined in my constructor from map to screen. The default, as I mentioned earlier, is map. I want to say output mode screen. And you'll see in a second what that does. So let me build this sample. And then I can directly start it in my debugger, which will open ArcGIS Pro. This is all set up and configured by the ArcGIS Pro templates. So once you install the templates from the Visual Studio gallery, you get all this functionality out of box. So by default, an add-in module, when I add it without modifications, it appears under the add-in tab. And as you can see, I must have played with it before, so I have another map tool here, but it's probably this on the right side, I hope. So if I click on Map Tool, so now I can perform a selection on the screen. It's probably hard to see on that screen. It selects my features and then it zoomed to the screen. So now you can see the features that are selected are just these points on my map. So if I want to do the same on a 3D map, I have a three-dimensional map of Portland City. Let me open this. And let me zoom out a little bit. So now when I select my map tool, I can actually perform a selection in 3D it will select the building that I just rubber banded, and it will zoom to that building. So if I zoom out a little bit, and I select the building here in the background, so you can see the functionality in the API works both on 2-dimensional data and on 3-dimensional data. So let me close this sample here. So this was a map tool created from scratch, out of box, just by utilizing the templates. So next we're going to look at graphics overlay. So this allows us to add graphics to Pro's graphic overlay itself. And in order to do that, you must use a geometry and a symbol. You can call the map tool base class, and there's a couple of methods that we provide. It's add overlay asynchronous, add overlay, or update overlay. And then to clear graphics that you added to your overlay, graphics are disposed when the tool is deactivated. Or you can do your own dispose to clear the graphics as needed, and we'll show you in a second how that's done. So here's a sample of a map tool that works with graphics overlay. So what we do here is we have a line symbol that we create in a helper method. So this is where we define a class called sim line symbol. We create an instance called underscore line symbol. And in the onSketch complete asynchronous method down here, we utilize the geometry and add that geometry using that line symbol symbology as an overlay. The returned object, we call it underscore graphic here. We keep it as a private member in our class. And when the mouse down is clicked again, we actually use that underscore graphic and we dispose of it. So this will clear the feature, the graphic that was drawn on the Pro overlay before. This will clear it from the display. And we have a little sample for the graphics overlay. So again, what I did here is I just created one of these map tools. In this case, I call it the Add Overlay tool. It also derives from map tool. I have my graphic disposable object. I have my line symbol. And now in this case, I set the sketch type to line. So this will allow me to draw lines on the screen. And then the output mode is map in this case. So when the tool is deactivated, I look at the graphic object, and if the graphic object has been defined before, I dispose it, which means that the feature will be cleared from the display. And on activate, I just initialize my line symbol to make sure that I have my line symbol defined. I also override the sketch symbol for my sketching that I perform in this map tool. And instead of using the out-of-box sketch symbol, I utilize my line symbol that I define. And then finally, here on Sketch Complete Asynchronous, I say take this geometry that I just sketched out, utilize the symbology from my line symbol, and then add it as an overlay to the current map view, and then return the value in my iDisposable graphic object. So let's see what this looks like when we run it. Let me rebuild this. Okay, I'm going to start the debugger. And I use different test data for each sample because some samples show better with different test data. So here's my little add overlay robot. I click on that button Now the tool is active. Here it gets constructed. Here the tool becomes activated. I override the sketch symbology. And now I can sketch anything on this map. So let me sketch a line here along this road. So when I finish the sketch, I can either use these buttons or I can double click to finish the sketch. So now the sketch is complete. My asynchronous sketch complete method is getting called. And if I look at this geometry over here that gets passed in, I can see it's defined and it's a polyline. It actually is the line that I just sketched onto the display. So now here we add this to the overlay itself. So when we continue, so you can see the sketch is complete and we now added our line with the various vertices to our display. So now, as soon as I mouse down, this graphic gets cleared. Let's try that real quick. I click somewhere else. So here's the mouse down. We check for the graphic. The graphic is unequal to null, and we call dispose. You can see that the previous overlay that we added is cleared. So now I can add my next one. It doesn't want to take double click, so I'll take the end here. And now this next feature has been added to the map. Now, if I want to do the same thing with sketching on, then I have the ability to turn some of the attributes on that are provided by the base class. So if we look at this, for example, so you can see for this sketch tool, I use snapping. So I want to actually snap to all the lines, points, polygons that are set up for my snapping environment, and I would want to use those. So this is just a property setting that I can turn on. But in essence, it's the very same class that you just seen. So back to the slides. So selection and identify. We usually use the sketch tool with a map view or individual layers to select certain geometries. So there's methods on the layer that require spatial query filter, but the methods on the whole map view don't require this because when you look at a function call that we use here, the first one is select features that is based on all the layers in a current map view. You just supply the geometry, the selection method, and it will return all the dictionary collection of your basic feature layers, one for each feature layer that fits your overlay geometry, with a list of all object IDs that fulfill the criteria of overlaying your sketch geometry. As compared to the layers themselves, if you look at feature layers, when you search for feature layers or do a selection on feature layers, you do have to provide a query filter. And if you used ArcGIS ArcObjects before, you know query filter very well. It's very similar. We're going to use a sample shortly that shows you how this works. So typically, we would execute the select or the identify in the callback itself, not on tool mouse down like you might have done in ArcObjects, for example. And so at that point, you can use a pop-up via embeddable control, or you can sync your result with a dock pane to then display those results. So down here, this is a little code snippet. On Sketch Complete Asynchronous, you get the geometry. Again, we run this to the task scheduler within ArcGIS Pro, so we use qtask.run. And within that, we perform the selection and then some custom action on our selection. So now specifically for map explorations, we have a pattern called the custom pop-ups. Custom pop-ups are actually implemented in code. And the format, the layout of a custom pop-up where you want to show the identify information uses HTML and JavaScript. So you can easily, and if you're familiar with HTML5 and JavaScript, you can easily provide a page that has all kinds of formatting, including charts, tables, etc. Very easy in HTML5 and JavaScript, a lot easier than in WPF. So we provide you the means, instead of programming this in WPF, in Windows Presentation Foundation, you can do it in HTML5 or JavaScript. It's not persisted in the layer definition, so it's not like a layer pop-up where you change the definition of your layer pop-up configuration. And to invoke in code, you have to use map view show custom pop-up overloads. So right here we have the map view overloads displayed, show custom pop-up. So we have one overload with an enumerable, which is pretty much an enumerable list of pop-up content objects. And you also have the option of having a enumerable of pop-up content, and then enumerable of pop-up commands, which are commands that you can custom code on the user interface that pops up. So we'll see that in a second. And then a flag here include default commands. There's a set of commands that come with the custom pop-up that you can choose to include or exclude. So to implement your own custom pop-up content, you have to first assign the map member and the ID, and then you have to provide the content formatting in HTML and JavaScript. So you see down here, in this code snippet, I create a new pop-up content instance, and I provide a map member, which is in essence the layer that is returned by my selection. I also have to specify the ID. Clearly, if I have a selection that goes over multiple objects or features, I would have to provide multiple pop-up content instances, all with different object IDs. And then I can provide a title, and then the formatting, the HTML content itself. So this would be a very simple HTML page down here that you see that just has a body. It displays the layer name and then the object ID. And then I would have to call on the map view the show custom pop-up, give it the list of my pop-up content that I created, and then that function will appear, the pop-up window will appear on top of my map. So we can also, there's a feature where we can implement the onCreate HTML content callback for dynamic content. So what you saw previously is pretty much the same content is created for every page. We just filled in the layer name and then the ID. So, but there's an opportunity here to defer the HTML content creation until the pop-up is actually shown. So in this case, you derive your own custom class from pop-up content. You set the isDynamicContent to true, and then you have to implement the onCreate HTML content method. So you see a sample down here. Here's my pop-up content custom class. It derives from pop-up content. I set isDynamicContent to true, so this indicates that I want to create each HTML page for every record separately, and then I have to implement the onCreate HTML content. And that's actually a sample that I'm going to show you right here. Just as a side remark, all these samples that you see here are available on our sample community page for ArcGIS Pro. So if you want to try them yourself, then feel free. So here's my custom pop-up sample. Again, I implemented a custom pop-up tool. Here is the method where I overwrite the returned geometry. I set a breakpoint right here where I get my features that I actually intersected by my sketch geometry. And here's where I provide my list or create my list of pop-up content. So let's set a breakpoint here and we'll see what happens. I think for this sample I need to utilize my election data. Election. Okay, my custom pop-up button is right here. This will activate my tool. As you can see, my selection sketch geometry type is rectangle. So as I continue, I can now rubber band across these features on the map. And my onSketchComplete async function was called with the geometry that represents the sketch that I just rubber banded across my map. I now call a method that's a helper method that I have to get me all the features that intersect this geometry. So result, when I look at result, it is an array. The array has an entry for each feature layer that I have on the map. The very first one, and the only one in this case, is US states. So if I would have had more feature layers on my map, I would have received more than one record. I would have received a record for each feature layer. But in this case, I only received one feature layer, which is the US states. However, when you look at the value itself, I have an array of 7 different values. These are the object IDs for each feature that is within my sketch geometry. So in this case, I have 2, 3, 5. These are my object IDs. I have a total of 7. So now down here, what I do is I create my pop-up content list. So I create one for each record, for each feature that I want to show in my pop-up content when it pops up. So as we go through here, you can see I go through my result. And then for each one of the results, which I only have one of, I go through all IDs. I create a dynamic pop-up. So this is my custom class, dynamic pop-up. And I pass in the key and the ID. The key is the name of the feature layer. And the ID would be my object ID. So once I'm done with this, let me set a breakpoint after this. So now if we look at pop-ups, we can see the 7 records that we had for our US states feature class are now transferred into distinct single records in my pop-up content list. I flash the features, and let's continue. We didn't see the flash, it's in the background. And now we call show custom pop-up. We pass in the lists. We also have a few custom commands that I have here. And then we say also show the default commands. I'll explain that in a second. But as I continue now, I will see the window popping up. And as you can see here, this looks very nice. This is HTML5 and JavaScript. And in order to prove this, let's take a look at the template I used. Which is template.html. So I actually used a Google visualization library It's a JavaScript library from Google. It's called Visualization 1.1. And you can see there's just standard JavaScript code that I just happened to copy and paste from a sample somewhere. I don't know JavaScript that well, but well enough to be able to implement the sample. There's one very specific line item right here, which is important for this, because the page that I render here expects the data to be available in a specific format. And what I do is, and we see that in a little bit later when we debug this, I prepare the data for each record, then replace the content / data.add column in my template with the actual data. So once the HTML5 page runs, the real content has been filled in and it's able to display me the content. So let's go back to our ArcGIS Pro. So now you can see some of the features of pop-up content. So the very first record that you see here is Washington. So Washington State, that would be. So if I flash this feature, you can see I have some of the tools that come out of the box, and some of the custom tools that I implemented here are available on the bottom status bar of my pop-up window. So when I click here, you can see the feature flashing on the display, and I can use the scroll bar to scroll to the next feature. So in this case, my HTML5 has just a standard list, and then it has a chart that compares Democratic votes and GOP votes from 2008. So you can scroll through here. Now, remember when I mentioned earlier that this is a custom pop-up? So the dynamic pop-up that I create, the HTML5, is defined for each page as soon as the record is available. And let's debug this real quick, and we'll take a look how that works. So in order to do this, we go into my custom pop-up class. And as I mentioned earlier in my slides, you have to override the onCreateHTML content method. This method gets called for each record that you select. So if I select the next record, my breakpoint here should get hit. So let me do the next record. And here we go. So here's the next record. So now what I have is let me scroll through this. Now I have the layer that we earlier used as the initializer for our custom pop-up method. I have the layer here, and I also have the object ID for that specific field. So I can use that information to retrieve all the attributes for the current selected record. So which I do right here. I create a where clause in a query filter, and in that where clause I now retrieve object ID 7th record. And then what I do build is a string using a string builder that has my content that my HTML page requires in JavaScript format. So I do this down here. You can see this is clearly JavaScript. I add columns to a data object here, JavaScript object. And when I'm done, let me do this here. Step to the next breakpoint. You can see that my JavaScript, including the data from my current record, has been added to my string. This might not be very readable. So now what I do is I retrieve my HTML template. So I retrieve that from a file. And then I replace the placeholder that I have in my HTML template file with the string that I prepared with all the data. So as I continue, the JavaScript executes for that page. It's using the data that I just passed in to my JavaScript, and it now displays this this record's content using HTML5 and JavaScript. So back to the slides. And this leads us to map controls. Uma is going to tell us about map controls, and then she's going to show us how to use renderers and apply renderers to feature layers.
So I'm going to finish up the map exploration section with a brief overview of the map control. The map control is a reusable control, and you can embed it in a dock pane, a view pane, a dialog, or pretty much any user control. You can use it to display various project items like 2D, 3D maps, layers, layer packages, and even raster data sets. So the map control has a view content property, and you can use that to define your display. And you can also use the camera property to navigate inside your map control. So the map control's content is created by calling the create method of the map control content factory class. There are many overloads for this create method. You can pass in various project items like a map, a scene, or a layer. And an important thing to remember here is that once you create your map content from a specific source, if you want to regenerate that content from a different source, you have to delete and recreate. So if your add-in uses an MVVM pattern, you can bind to your content to the view content property of the map control. So the map control exposes a bunch of events, like the extent changed or the camera changed event. You can listen to, for example, you can listen to the extent changed event, and when the map control's extent changes, you can sync up your workflows for that. And on this slide, I've also listed some of the commands exposed by the map control, so you can use that to manipulate the display of your map control. So now I want to show you a little overview window map control sample. So I'm going to go into Visual Studio. So this is pretty much an add-in project type. In this particular sample, I want to embed my map control inside a dock pane. So to an add-in project type, I have added a dock pane item template. So what you see right here is the XAML of the dock pane. And over here is the map control. I've just added that to the dock pane. So now let's go see the code behind for the dock pane. In my constructor over here, the first thing I've done is I've assigned a map control variable to point to this map control that I just showed you in my XAML. And right here in this method, initialize map control method, this is where I am initializing the content. So let's go see what this method does. So the first thing I'm doing here, I'm listening to a couple of events, an active map view changed event and a map view camera changed event. When these events get triggered, I want to reset the contents of my map control. So that's what I'm doing there. And then I am checking if I'm in a 2D map. And the first thing I'm doing here is calculating the extent that I want to display. I am tying it to my active map view. So I'm calculating that extent. And then this is where I'm calling the create method of the map control content factory to generate the content I want to display. So let's see how this looks in Pro. I'm going to start Pro through the Visual Studio debugger. I'm going to open this map control project. Okay, so now this is my dock pane that I've created where I've embedded my map control. So the first thing I want to show you is a few things that I get out of the box. I'm going to first undock this so that I can show you my content pane. Okay, so out of the box, my map control respects my layer visibility. So for example, if I turn this Portland Precincts feature layer off, notice that it's off in the map control also. I get this out of the box with no code. I'm going to turn that back on. And then in Visual Studio, I'm going to disable some of my breakpoints here. So here in the map view camera changed event, I'm going to add these breakpoints and back in Pro. So I'm going to pan my active map view. So now you can notice that my breakpoint inside my map view camera changed event has triggered. And the first thing I'm doing here is I'm calculating the extent of the active map view. So I'm going to continue. And now I'm within this queued task lambda over here, and I'm going to create a red line symbol to draw my overview window. And then this is very similar to what Wolf showed you with the add overlay graphic. I'm checking if my graphic exists, and I'm disposing it. I'm going to continue. And right here, I'm setting my overview envelope to be the extent of my new active map view. And over here in a series of code, I'm just calculating the line segments that correlates to the vertices of the overview envelope. And using those segments, I'm creating a polyline using the create polyline method on the polyline builder class. And right here, I am creating the graphic. I'm using the map controls add overlay method. I'm passing in the polyline that I created and the red line symbol. So let's continue. And you can see that my map controls red rectangle has changed to mimic what I did in my active map view. So let me go ahead and disable my breakpoints. And I want to show one more thing in the map control. So now I'm also listening to the extent changed event triggered by the map control. So what that means is if I change the extent defined by my map control by panning this, notice that my active map view also changes. So how did I do that? So I'm going to go inside my project right here. I'm going to add a couple of breakpoints inside my map control extent changed event. So let's see what this does. So I'm going to pan inside my map control. And the first thing that I'm doing is I'm calculating the map controls extent. And then I'm calling the zoom to method of the map view, and I'm giving it the extent within the map control. I am expanding it by a factor of 1/4 because, again, this is an overview window, so that's the expand method I'm using to achieve that. And you can see that my active map view has also changed. So as you can see, the map control has some neat built-in functionality, and it has some API methods that you can use to customize it. So let's move on back to the slides. Okay, so before I move on to the feature renderer section, I want to recap certain key concepts of the map and the feature layer. The map, it holds all your geographic data, and it's a container for your layers and your tables. So if you want to access all the layers within your map, you call the layers property, and to access the tables within your map, you call the standalone tables property. And over here, I've also given you a code snippet of a convenient method, the get layers as a flattened list. This pretty much returns all the layers in your map as a flat list, even the layers within your group layer. So now the feature layer is derived from a layer, and it pretty much allows you to draw the underlying features on the active map. So what is a feature layer renderer? Every feature layer has a renderer. So the renderer symbolizes the feature and it displays that on the map. So the Pro SDK API provides various methods to create renderers. In this particular session, we're going to talk about 3 renderers. We're going to first talk about the simple renderer, and then I'm going to cover 2 types of advanced renderers, the unique value renderer and the procedural symbols. So a simple renderer, it pretty much renders all the features with the exact same symbol. So this code snippet here, it renders a polygon feature layer with a red fill and a blue outline. So the first step, as you can see, is I'm creating my polygon symbol, and then I'm using the layers get renderer method, which returns a simple render object back. And then I am assigning my newly created red symbol to this renderer. And then the last step, I am calling the set renderer method on the layer to update the layer. So we'll see all these renderers in a demo shortly. So an advanced renderers, as soon as you try to use an advanced renderers, you have to start with a renderer definition class. So there are many renderer definition classes available, and you can see them listed over here. There are about 6 of them. So as an example for a renderer definition, I'm going to use unique value renderer. And as you can see, it's a kind of like a 3-step process. The first, you define a renderer definition. So I'm going to define a unique value renderer definition using its constructor. I'm assigning the parcel type as the field for the value fields, and I'm using one of the pre-designed color ramps found in Pro. Then now that I have a unique value renderer definition, I am creating a renderer object. I'm calling the create renderer method on the feature layer, and I'm passing in this definition. So I get a renderer back. So again, the last step is exactly the same as the previous one. I'm calling the set renderer method on the layer, and that will redraw the feature layer with this newly defined unique value renderer. So moving on to procedural symbols, new at 1.4, you can create a symbol with a procedural symbol layer from a rule package. So the code in this slide looks a little involved, but we will step through this in the demo next. So over here, I have a project where I've added 3 buttons with 3 different kinds of renderers that we just looked at. I'm going to, before I look into the code, I'm going to start the debugger. Let's see how it looks in Pro first. So I have a project here called the Venice project. So this is a scene that loads a polygon feature layer Venice structures. The pale blue, pale beige outline here is the outline of the buildings in Venice, and you can hardly see it, and we're going to enhance this view using our renderers. First, on this renderer tab, let's render this feature layer with the simple renderer. So I'm going to click this button. My breakpoint is hit behind the on-click event. And if you notice here, this code right here is exactly the same as the one you saw in the slide. So first, I'm creating a polygon symbol. It's red with a blue outline. I'm using the construct polygon symbol on the symbol factory class. I'm passing it the red color. It's a solid fill and an outline of blue. So I'm going to step over that. And over here, I am calling the getRenderer method on the layer, and this gives me the renderer applied to the current layer, the pale beige color, right? So now what I'm doing in the next step here is I'm assigning the newly designed polygon symbol, the one with the red fill, I'm applying it to my renderer. And the last step, I am setting the Venice feature structures, Venice building structures. I'm setting this renderer using the setRenderer method. So let's see how that looks in Pro. And you can see that it's rendered with those red polygons. Not really that interesting, but it at least stands out a little bit. So now let's use the next kind of renderer we discussed, which is the unique value renderer. So I'm going to use this feature, that layer that I have, the Venice structures. It has the roof fields for all the structures in Venice. So I want to categorize based on that. So I'm going to click the unique value renderer. And again, this is the exact same code from a slide. The first thing I'm doing here is I am creating a unique value renderer definition. So I'm passing in my roof fields to the value fields in the constructor, and I'm picking one of the pre-designed color ramps in Pro. So in the next, right here, I'm creating a renderer using the layers create renderer method. I'm passing in my unique value renderer definition, and I get a renderer back. So again, it's the same last step. I'm applying this renderer to the Venice structures feature layer. So let's see how that looks. So here you have a little more information. You see that the red polygons are the gable roofs, and green is the pyramid, and then there's another roof type called shed. So let's see if we can make this look better. So now I'm going to try to render this using a Venice rule package that I have downloaded on this machine, and I'm going to create a procedural symbol layer using that rule package. So let's see how I did that. So I'm going to click this to see the code behind. So the first step, I'm getting the renderer of the Venice structures layer. So the next step over here, I am creating a map layer fields to rule package inputs array. So what I'm essentially doing here is that I know that my Venice rule package has certain properties exposed in it. It has a number of floors property right here, and I want to link it to the floors field of my Venice structures feature layer. So I'm just creating an array, and then I'm using the roof type property of my rule package, and I'm assigning it to the roof fields of my feature layer. So I'm just creating an array over here. So this is where the magic happens. So new at 1.4, we have this construct procedural symbol method on the symbol factory, and it takes in a rule package. It takes in my feature layer, my Venice structures feature layer, and I pass in that mapped array, the one that I mapped the rule package property to my fields. It takes in that as the third parameter. So I'm going to step over that. And one thing I forgot to mention here is the construct procedural symbol method. It returns a symbol reference. So using that symbol reference, I'm creating a polygon symbol object. So this polygon symbol contains the procedural symbol layer. So I'm going to continue. And since I'm working with 3D, I need to convert this polygon symbol to be the same as that of my feature layer. So that's what's happening over here. And then here in the next step, I am assigning this newly created symbol to my renderer. And the same last step as we've been doing for the other two samples, I am setting my Venice feature layers renderer using the setRenderer method. So now let's see how this looks in Pro. Just give it a minute. And the Venice structures is now rendered with this polygon symbol with a procedural symbol layer. So you can see way more detail, and you can even take this a step further, and you can use the GP tool and export it as a multi-patch layer. So now going back to the slides, I have one more slide. This slide basically, you can use the layer factories create feature layer, and you can create a layer with a renderer in it all in one shot. So it minimizes code, and it's a convenient method. So that concludes our presentation. Thanks for attending our presentation. And here I have a slide that lists other SDK-related sessions. And you can notice that I've also added a rule package session over here, just in case if you want to learn more about rule packages and how you can use that in ArcGIS Pro. Then here I've listed our demo theater sessions, and there's an ArcGIS Pro SDK Road Ahead session also listed here. And then new this year, we have an instructor-led Pro SDK training. It's called the Extending ArcGIS Pro with Add-ins. It's a 3-day class, and it's coming up in April. And there are seats available if you would like to sign up.
Also, the samples that we showed you tonight, they are virtually all available on our Pro SDK community sample site. If you search on Google and you search for ArcGIS Pro SDK, you will end up on our landing page. And from there, you can go to our Pro Concept, Pro Guide documents, to our samples, where you find plenty of these samples and similar ones. Okay, we got a few minutes for questions. Do we have any questions? Yes, sir? I didn't quite understand. Volume-wise, I didn't understand your question. Right. So the question is, I think we already had a unique value renderer in there, and couldn't we have just changed the unique value renderer? Is that what you meant to say? Because I think in your set method, we created a different renderer and just replaced the unique value renderer using the set renderer function. If she brings up the sample here.
So this is where I'm creating the actual unique value renderer definition. So this is where I'm passing in the field to use. And then, so here, this is where I'm actually creating the renderer. This was just the unique value renderer definition. And using that definition, I'm creating the renderer. So that's this method. So at this point, I get an actual renderer object back, and then that's what I pass to the set renderer method.
But I think your question is, can we get the current renderer and make modifications to the current renderer, right? And I think that's possible. Yes. We don't have an example for that. We just created new ones just to show you the samples, but we could have made changes, yes. All right, I see no more hands. Thank you for joining us tonight, even in this heat. This is Palm Springs. It gets very hot. All right, enjoy the show, and thank you very much.